As you've seen in the previous video, the price of a good plays a central role in the quantity that consumers demand. Think of all the times you've said to yourself, "I'd buy one of those if they weren't so expensive," or "What a great deal, I'm going to buy a lot of these." Economists use a demand schedule and a demand curve to summarize the relationship between the quantity of a product demanded and its price. Let's start with the demand schedule. A demand schedule is a table that indicates the quantity demanded of a particular good at various prices. To illustrate how a demand schedule is constructed, let's imagine interviewing a driver named Alicia about her purchases of gasoline. We can ask Alicia, how many gallons of gasoline would you purchase each month if the price per gallon were $2? If she answers 20 gallons, we record in the demand schedule that at a price of $2 per gallon, the quantity demanded is 20 gallons. Then we can ask Alicia how much gasoline she would buy if the price increased to $2.50 per gallon and nothing else changed. If her response is 15 gallons, we record in the demand schedule that at a price of $2.50, the quantity demanded is 15 gallons. We could continue to ask about the quantity she would purchase at different prices and record her answers. This table right here displays Alicia's demand schedule for gasoline. Notice that as the price of gas goes up, the quantity of gas Alicia demands goes down. High gas prices might motivate Alicia to use public transportation, take fewer unnecessary trips, ride her bike more, and carpool with friends. The demand curve is different. It's a graphical representation of the demand schedule, showing the quantity demanded at each price. Although it is called a curve, it is sometimes a straight line, as shown here. Each price and quantity in the demand schedule is represented by a point on the demand curve. Let's draw Alicia's demand curve for gasoline using the information from the demand schedule in the figure. In the first row of the demand schedule, we see that at a price of $2, Alicia buys 20 gallons of gasoline per month. That is represented by the point on the far right of the graph. The price of $2 is measured on the vertical axis, and the quantity of 20 gallons is measured on the horizontal axis, also called the x-axis. As you can see from the graph, Alicia's demand curve slopes downward and to the right. Which means that the lower the price, the more gasoline she buys. For example, if the price falls from $3 to $2, Alicia's quantity demanded rises from 10 to 20 gallons as we go from 3 to 2, because we're going from here to here. And so you can see the change. This change in the quantity demanded is represented as movement along the demand curve. We call this a movement along the curve because to illustrate what happened, we can simply slide a pencil along the curve, just like this, to move from one point to the next, moving from $3.10 gallons to the point representing $2.20 gallons. Notice that the curve itself does not change position. All that changes when the price changes is the point on the curve that indicates the quantity Alicia purchases at the current price. When the price changes, we move along the demand curve. This is the law of demand in action. We started our study of demand by looking at the behavior of a single consumer, Alicia, in the previous figure. The people who run businesses and make economic policy, however, are often interested in the demand curve of all the consumers of a good combined. The market demand curve is a graphical representation of the quantity of a good demanded by all consumers in the market at each price. To see how the market demand curve is drawn, let's suppose that there are two consumers in the market for gasoline. We have Fred and we have Alicia. Fred's demand for gasoline, like Alicia's, can be summarized in a demand schedule and provide Fred's. Notice that at each price, Fred demands more gasoline than Alicia does. At $2, he demands 30, she only demands 20. At $2.50, he demands 25 gallons, she only demands 15, and so on. But why is this the case? Well, maybe Fred has a longer ride to work each day, or he might drive a big car because he has a large family, while Alicia drives a hybrid car that gets better gas mileage. Notice that regardless of their differences, Fred and Alicia each demand less gasoline at a higher price than they do at a lower price. We calculate the market demand by combining the two. We add together Fred's and Alicia's quantity demanded at each price, as shown in the fourth column of this table. For example, at a price of $2, Alicia demands 20 gallons and Fred demands 30 gallons, and so that equals the 50 gallons that would be demanded by the market. At a price of $2.50, Alicia demands 15 gallons, Fred demands 25 gallons, and that equals the market demand of 40 gallons. So the quantity demanded in the market is stated in the final column, and we would continue in this fashion, combining all the quantities demanded at each price to complete the table. The graph in this figure shows the market demand curve drawn from that information. Like the individual demand curves, the market demand curve slopes downward as the price falls. The quantity demanded collectively by Alicia and Fred rises. The law of demand thus applies to the market demand curve as well as to the individual demand curve of each consumer. So here you see Alicia's demand curve and you see Fred's demand curve, and their individual demand curves are different, but we sum these two individual demand curves together. Notice the plus sign there. And when we sum all of the individual demand curves together that are different, we end up with the market demand curve. From now on, in this course, we will be looking at market demand curves rather than the demand curves of individual consumers. So when you see the term demand curve, it will refer to the market demand curve.